Dependency injection is a must-have in every professional developer's toolkit, but for beginners, it's very intimidating. It has a big fancy name, and a lot of times when people are trying to teach it, they're doing it later on in the learning experience, and I found that they tend to pack too much complexity into their example. So what I would like to do today is take some code that's very simple, written the way a beginner would write it, and we will refactor it to use dependency injection so that we can demonstrate the basic concepts. I'm Eric Wise from Skill Foundry, where we teach people how to code the right way. For a sample application, we have two files. We have a game manager and we have program.cs. Now the game manager is just a very simplistic class that plays a round of rock, paper, scissors. And what it does is it uses two enums. We have a choice, rock, paper, or scissors, and we have the result of the round, which either player 1 wins, player 2 wins, or it's a draw. And this game manager class has one private field, which is a random number generator for the computer to pick a choice, and it has a method called playRound. And the playRound method, first it prompts player 1, which is a human, for their choice, and it converts RPS to a choice of rock, paper, or scissors. And if they don't enter RPS, it's going to prompt them to enter it again. Now player 2, the computer, it's going to generate a random number. It's going to convert that to a choice, print out what they picked, and then it's going to determine whether the result was a draw, or if player 1 wins, or if neither of those two things happen, then player 2 wins. Over in program.cs, the only thing we're doing is creating our game manager object, and then we put in a do while loop so that it will continue playing rounds so long as the player says that they want to play again. And it takes that round result from the playRound method, and it just parses it out in an if statement and prints out the result. And if I run this, you'll be able to see very quickly that this application does work. So I can enter rock. Player 2 also picked rock, it was a draw. I can enter scissors, they picked rock, so they won, and so forth. So the application is clearly working. The application is really simplistic. But this application has some pretty serious problems. The main one being, how do you test it? And the answer is you can't. You cannot write automated code tests for the playRound method. For starters, it goes to the console. It requires human input to run, and that can't easily be automated. And number 2, because the computer gets its data from a random number, we can't control what the computer picks. And if we can't control what the computer picks, that means we can't write tests for it because we won't know. So the only way to really test this application right now is to brute force it and just run it over and over and over again and hope that the random numbers line up in a way that you can test every possible combination. That is not efficient. That is not how professionals like to write code. Now, as a beginner who does not know dependency injection, you might start thinking of some ways to solve this problem. And usually what it involves is, hey, we could add some parameters to the playRound method. We could pass in maybe a Boolean that would put it in test mode. And then we could add a bunch of if-else statements and kind of put that test code inside the game manager class. And that's bad, because now anytime in the future you want to change the behavior of how a choice is received, you now have to edit the game manager class. And what happens if you accidentally break one of the other choices? How big and complicated is that class going to get as you add more and more if-else statements? Because if you think about it, you need every permutation of choice. You need rocks, papers, scissors, all of those. And this is where the concept of dependency injection comes in. The question we need to ask is, does the game manager really need to be concerned about how player 1 and player 2 arrive at their choices? And the answer is no, it doesn't really need to care. What the game manager cares about is it says, hey, player 1, give me your choice. Hey, player 2, give me your choice. It doesn't care if it's random. It doesn't care if the choice comes from the console. It doesn't care if the choice is hard-coded. This is where dependency injection shines and what it tries to accomplish. We want to decouple the game manager class from the implementation of how a choice is made. So now that we see the problem with the game manager class, let's talk about the term dependency injection. This game manager play around method, it depends on two choices being made. You cannot play a round of rock, paper, scissors without getting those two choices. But what we don't want it to do is be concerned with these details. It should not be managing the process of how player 1 determines its choice. And it shouldn't be concerned with how player 2 gets its choice. It should just ask for them. So what we're going to do is we're going to pull this code out of the game manager class. It's still going to exist, but we're going to put it in different objects. And those become like swappable components. So dependency injection, it depends on a choice. And because we've moved the code somewhere else, we're going to inject the code at runtime into the game manager. We're going to say, hey, game manager, here are the two objects that are going to give you your choices that you need. And the game manager is going to say, great, object 1, give me your choice. And that code will execute and it will pass the choice up. And then it will say, hey, object 2, give me your choice. And that object's code will execute and it will give it the choice. The game manager will not see or care where that choice came from anymore. It depends on it, but the objects are going to be injected. So when you think about dependency injection as a term, all we're talking about is being able to swap in objects that have different implementations, which is how they do their jobs. Now, as we jump over to code, the first step of dependency injection is taking that behavior we want to swap and expressing it as a method, because that's what an interface really is. It is a list of methods and behaviors that every object that implements that interface must have. Now, for rock, paper, scissors here, this is really simple. It's only one method. It needs to get a choice from a player. So let's go ahead and name the interface iPlayer and define one method stub on it called getChoice. So we'll go ahead and do that. We'll add a new item. It'll be an interface. We'll say iPlayer, and it will have one method stub on it, and it will be getChoice. Just like that. And now the interface has been defined. This is the only thing the game manager needs to do its job. It needs a choice. Doesn't care where it comes from. We care, so let's go ahead and put in two implementations. So let's add a class, and we're going to call this the human player. And the human player is going to implement the iPlayer interface. And when we do that, we have to put all the members from the interface into the class. And we defined getChoice, which returns a choice. Now what we can do is go over to our game manager and go ahead and just copy all of this implementation code, and we can put it in the human player. And at the end of it, we'll return the choice. Just like that. And now all of that logic has been moved out of the game manager. It's now in this human player object, ready to go. And the second thing we're going to do is create a class for the computer. So let's say computer player. And same thing, we will implement the interface iPlayer, which will require us to put the choice method on there. And this class will also need the random number generator, just like we did before. And now back in the game manager, it doesn't need this anymore. It can take out the implementation from the computer, and we can move that into this method, and we can return it. So just like that. So now all of our implementation has been removed from the game manager. The computer player, when it's asked to get a choice, will use a random number. The human player, when it's asked to get a choice, will prompt the human player using the console. So the behavior of the game hasn't changed, it's just moved into two different components. Now going back to the game manager, this class is no longer happy because it has variables for choices, but it has no way of getting them because we've removed the implementation and moved it out to the human player and computer player objects. So the next step is to create fields that hold iPlayer objects that the game manager can ask to get its choices. Now in dependency injection, there's a couple different ways you can pass objects in, but the most common is to use a constructor method, and this is called constructor injection. All we're going to do is say, hey, when you create a new game manager object, you must also pass it the objects that will get the choices for it, the objects it depends on. So what we're going to do is in the game manager, we're going to create two fields of type iPlayer. And we're just going to call this player 1. And we're going to call the other one player 2. And then we're going to add a constructor method where we're going to pass in two iPlayer objects. Now, we're coding to interfaces, not to the implementation. We will never mention human player or computer player in this class because this class doesn't care. All it needs is an iPlayer. Doesn't care what kind, and it's going to ask it to get a choice. So you're always going to only use the interface in the injected class. So we're going to say iPlayer, player 1, iPlayer, player 2, and then in the constructor method, we're going to populate our local fields so that that data is saved in the object. Just like that. And now in our play round code, all we're going to do is say choice P1 equals, and we're going to ask player 1 with the interface to get its choice. And then we're going to do the same thing for P2. We're going to ask it to get its choice. And now we're done with this class. You're going to give it two implementations of iPlayer. It doesn't care if they're human, computer, or any other implementation we might have. The only thing it's going to do is receive those components, and then it's going to ask those components to get the choice. No longer cares where the choice comes from. Doesn't matter because it's going to run the game regardless. And let's go ahead and put a message in here just so we know what people picked. So I'll say console.writeLine. We'll say player 1 picks that. And then we'll say, and player 2 picks that. Just like that. And now we'll know what they picked. And the last step here is to go out to our program, and when we create our game manager, we do need to give it the components now. So I'm going to say new human player and new computer player. Just like that. And if we run the game now, it should work the same way it did before. And you can see it's prompting the human player. And if I choose that, scissors, paper, player 1 wins. Do I want to play again? Yes. If I pick rock, rock, scissors, I won again. I'm lucky today. But you can see now that we've refactored the code and not broken the application. But the game manager has no idea where the choices are coming from. When we ran the program, we told it use the human player and use the computer player. And now this is where the unit testing part comes in. So to speed things up, I've taken the liberty of adding a test project to our solution. And we're going to keep our test code cleanly separated from our game code. And this is one of the other benefits of dependency injection, is that you can keep this stuff separate. It doesn't pollute your production code. Now, what I need to do to write tests is to be able to force a player to pick the choice that I want it to pick. And I need to do that without going to the console because I want it to be automated, and it can't have random numbers. But now that I have the iPlayer interface, I can just write an implementation that returns whatever value I tell it to. So let's go ahead and do that. I'm going to add a class to my test project. And I'm going to call this the forced player because I'm going to force it to do what I tell it to do. So we'll say forced player is an iPlayer. We'll implement the interface. And just because something implements an interface doesn't mean you can't add extra stuff. The only thing it means is that the extra stuff, the game manager won't be able to see it, but that doesn't matter because I'm going to set all this stuff up before it gets to the game manager. So what I want to do is create a private field that represents the choice that I want it to have. So we'll do this, and then I'm going to add a constructor, and I'm going to pass in the choice that I want it to use. Just like this. And then I'm going to say the internal choice is equal to the choice that I pass into the constructor. And then when I ask it for the choice, I'm just going to return the thing that I set up. And now I can do this to always pick rock, always pick paper, always pick scissors, and I can use that to force wins, losses, and draws, as we'll see. Let's jump back over to the test class and create our first test method. And we'll say public void rock beats scissors. Just like that. And I'll say create a game manager. Now, because of the dependency injection, I need to give it 2 player objects. Well, I'm going to give it 2 force player objects because I want to force them to give the values of rock and scissors. So I'm going to say new force player, and you will pick rock. And then the second one will be a new force player, and you will pick scissors. And I hope you can see at this point that I can now force it to pick anything I want, which means I can write all of the permutations of the tests very easily. So I'm going to say game manager, play round, and I'm going to assert R equal. We're going to say round result dot player 1 win of the play round, just like that. And then I can go into my test explorer and I can run all my tests. And we'll see here, that it will run that code. And if it goes green, we're happy. And there it goes. It went green. So I forced it to pick rock. I forced player 2 to pick scissors. And then I tested that player 1 wins when the game manager plays the round. So you can see that I could set up multiple tests now and just change these values in each of those tests to all of the permutations that I want. And it's very easy for me to do. And that's not all that this dependency injection does, because now I can swap in any object that implements iPlayer. So what if your boss came to you and this was a game you were running on the job, and your boss said, hey, we would like a computer player, but we want it to pick rock 75% of the time. Well, that's easy. You just add a new class, you implement iPlayer, and you write the getChoice method to pick rock 75% of the time. So it's super cool like that. In fact, I can go back to the program and I can change this to computer player, and I can make the computer play against itself. And I don't even need to make any changes to the game manager anymore, because the game manager does not care where it gets its choices. And this is the true power of dependency injection. We're swapping behavior by moving the behavior out to components and then telling the class that uses the behavior, here, use this component. No, use this component. Or maybe you should use this component. But I can add an infinite number of implementations of this interface now, and I never have to rewrite my game manager class. And it also means that I can keep things separated, like my test code from my production code. And this is why dependency injection is really important to professional developers, and it's a concept you need to learn and master. Now, I agree, it's confusing at first, and it takes a lot of practice because you have to get practice identifying these behaviors and moving them out into interfaces. But the concept of dependency injection is not overly difficult. All it means is moving implementation code to components and then rewriting the class that uses those components to be very generic, such that we can swap them out however we want. And it's always just making methods for behaviors and then writing the behaviors. So I hope this helped you out with your knowledge of dependency injection. I hope this made you a little more comfortable. It's still going to need practice, but I'm confident that with enough time, you're going to get it. Happy coding.